Hello everyone. In this video lecture, we are going to see the introduction to linear regression. Linear regression is one of the easiest algorithm in machine learning, and it is the most fundamental algorithm because it helps you to build the logic that how machine learning works, how the algorithm are made, and what is the maths of gradient descent, which is the one of the most important algorithm in machine learning as well as deep learning. So let's begin. Linear regression. So first it is regression. Regression means we are predicting a continuous value and it comes under the supervision category. So by regression we mean that we are predicting a value. Predict continuous value. Continuous value. Okay. And linear here says that there is linear relationship. Linear relationship between output and the predictor means input, the feature which is used as input, it is called predictor, between output and predictor. Okay, so from linear regression we concluded that there is linear relationship between output and the predictor or the predictors. Now there are basically two type of linear regression. First one is simple linear regression, and second one is multiple multiple linear regression. In simple we have only one predictor, and multiple it has more than one. Okay, so in this video we are going to see the introduction of this simple. Okay, so what is the linear regression, what it does? So it predicts the continuous value which has linear relationship with its predictor. So let's take an example. Let's say I have given you the data of a car, that mileage is given as input, mileage, and from mileage we are going to predict the price. Okay, so this problem can come into the linear regression class. So how we decided that? Let's say we plot the graph. We plot the graph of mileage versus price. On here we have mileage, and on here we have price. Okay, so let's say the data is something like this. These are the data points, let's say. So you can see that it is following linear trend. See, they are following linear trend. In linear regression, we have output which is linearly dependent on inputs or predictors. And in simple linear, we have only one predictor. So in case of simple linear, we can write that y equal to mx plus c, y equal to mx plus c, because it is a type of linear regression. And in simple linear regression, we have only one predictor and output is linearly dependent on predictor. So we can write y equal to mx plus c, where y is the output and x is the input. So in our case we can write as price equal to mileage into m plus c. So here m is the slope, wherein y equal to mx plus c, wherein y equal to mx plus c, m is the slope, and c is the intercept. C is intercept. Okay, so linear regression says that uh, there is linear relationship between output and input. So what is the job of linear regression? It is to find m and c. It is to find m and c. Okay, but think, in real life, do we get such a linear data? The answer is no. No, we don't always get linear data. Instead, what we have, if you see the previous graph also, these points do not follow the line, means all the points are not on the line. There is distance from the line. Okay, these points are somehow far away from the line. They are not lying on the line. They are not on the line exactly. So in real life data, what do we have? We have yx plus c plus we have noise plus we have noise. Y equal to mx plus c plus noise. Now the problem here is we cannot find a line that uh, that covers all the points, means that fits all the data point. So now we have concluded that in linear regression we have some noise because the real world data don't follow line. So there will be noise always. So can we say that there will be difference between the actual value and predicted value? Because what we were doing, we have said that y equal to mx plus c. There is a relationship. This is for our model. This is this y, or rather we should define it as a y hat equal to mx plus c. But in real, we will what we will have? We will have y equal to mx plus c plus some noise. Okay, and this noise varies for data point to data point. So can we say that there will be always a difference between y and y hat? Think what we are saying, that we are building a model. We are building a model which predicts the price from the mileage, and because it is linearly dependent, so we can write this predicted value. This is predicted. Y hat means predicted. Let me mention here. Y hat is predicted and y is actual. Y is actual. So can we say that there will be always difference between y and y hat? Which is this noise? This difference is, if you see the difference, then it is the noise. And this noise varies from data point to data point. So can we say that the difference between y and y hat will be varying for data point to data point? So can we measure the total difference? Yes. So how can we measure the total difference? So there is one method that we can take y minus y hat and sum it over for all points. Let's say for I one for n data points. So we can say that for I equal to 1 to n y minus y hat, where y is the actual and y hat is the predicted. But there is a problem. What is the problem? That let's say for some y minus y hat will be positive and for some it will be negative. So overall will be 0. So this is not we want now. We want to consider the negative also. So what we do? We add mod to this. We add mod to this. Now this will be always positive. Now the total difference between the summation of yi minus summation of y minus y hat over I equal to 1 to n. Okay. But now there is since also a problem. The problem is that will be discussed in the next video when we will discuss the maths behind this linear regression. So we will use this for I equal to 1 to n, and this is the total loss. This is the total loss. Okay, this is the total loss, and this loss is called cost function. This function is called cost function. Cost function. If you don't understand, let's see in furthermore. Cost function. What we are saying that there is a linear relationship between output and predictor, and we have found y hat equal to mx plus c. Now we find m and c. Now how do we measure the loss? We have used this cost function. This cost function of y hat minus y whole square. If you don't add mod here, then it is also okay because it is going to be squared for I equal to 1 to n. So what is this y hat? What is this y hat? Y hat is nothing but y hat equal to mx plus c. So we can write it as for I equal to 1 to n y minus mx minus c whole square. So we can write this function as j of m and c equal to I equal to 1 to n y minus mx minus c square. So this is the loss function or the cost function. Rather, I would say cost function. This is the cost function of linear regression. Okay, why we have used square, that will be discussed in the mathematical intuition video. So this is the cost function of this. linear regression. So more or less we have concluded that linear regression, it is the type of regression in which there is linear relationship between output and input, and we are supposed to find this best value of m and c which minimizes this function. We are supposed to find best values of m and c which minimizes this function. Now let's understand on the geometric manner. So let's see what I'm saying. That let's say these are the points. So the points I'm doing, this is one point, this is another, 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 and this is another. We can see that it is following the linear trend. Okay, let's say we have found one line like this. Okay, we have found another line like this. Okay, and we have found the third line as this, let's say. So if you see which line is the best, obviously the blue one. Okay, this is the, by seeing the graph we can see, but the blue line we will have this minimized function, but the blue line will have this minimized function. For the slope and intercept of blue line, this function will be minimized out of these three lines. But we can have multiple lines, infinite lines, because there is infinite values of m infinite values, and c also infinite values. So we can have infinite lines, but the line which has the minimum value of this cost function is the best fit line. So again, the goal of linear regression is to find such m and c which minimizes this loss function, cost function, which minimizes this cost function. And what the cost function is? The cost function is sum of square of difference between actual value and predicted value. Sum of square of difference between actual value and predicted value. So this is the logic behind linear regression. Okay, I hope you found this video helpful, and the PDF of this writing I'll upload on GitHub, and I'll add a link in the description below. Okay, thanks for watching.